Okay, so let's talk adding and subtracting with mixed numbers. Just like if you're adding or subtracting with fractions, you have to have the fraction part of your mixed number in a place where we have a common denominator, where the denominator is the same for the first addend as the second addend. In the problem I have right in front of us, we're dealing with thirds and we're trying to add fourths to those. Well, that's not going to work out. We need to create equivalent fractions to this 1/3 and this 1/4 that can be added easily. So we're going to have to find a common multiple. Now, if all else fails, I can always multiply 4 and 3 and get one common multiple. But I like to find the least common multiple and be pretty sure I'm on the right track with that. So I start listing the multiples of each of those denominators. And by multiples, we're just talking about skip counting at this point. And it turns out that 12 is the least of the common multiples, the smallest number that we can use to create an equivalent fraction in thirds and to fourths. So how do we do this? Well, we have to take a look and think, okay, if I'm going to go from fourths to twelfths, what's happening there? Well, to get from 4 to 12, I'd be multiplying by 3. There are 3 times as many twelfths as there are in fourths if we were looking at one whole divided into twelfths. So whatever I'm doing to that denominator, I'm going to do the numerator. And in this case, it's multiplied by 3. 1 times 3 is 3. So 1/4 is equivalent to 3/12. Now when I'm talking thirds, twelfths are 4 times. There are 4 times as many twelfths as there are thirds in any given whole. And so whatever's going on with the denominators is again going to be going on with those numerators, and 1/3 turns out to be equivalent to 4/12. So now I have been able to find that common multiple and create equivalent fractions, fractions that I can actually add because I'm counting the same things, twelfths. I have 4 and 4/12 plus 2 and 3/12. Well, my whole numbers, 4 plus 2, it's going to get me 6. 4/12 plus 3/12, it's going to get me 7/12. So now I've added. And the last thing I need to do is take a close look at my sum, 6 and 7/12, and ask myself, can I simplify this in any way? Well, I look at this fraction 7/12 and I realize that there are no common factors other than 1 to 7 and 12. There's no way I'm going to be able to divide that and reduce it to any simpler terms. So this is my simplest form sum. Go back and think about these 4 main steps. Finding a common multiple, creating equivalent fractions that you can then add and subtract, and once you have done that, what do we have to do to get to the simplest form, the simplest expression of the sum or the difference? Give it a try, take your time, you're going to be okay. Now let's take a look at a subtraction example, and we're going to really follow the same basic process. Again, I'm looking at my denominators and I'm seeing I have sevenths and thirds. Well, those are not the same. Adding sevenths to thirds is just too tricky. I want to think of this in terms of equivalent fractions. So again, I'm going to think of the multiples of each number, maybe going to list them because I tend to like to put my thinking on paper so that I can remember what I was thinking later. And, you know, so far, I'm not having a lot of luck. I'm going to keep going with my 3s. 15, 18, 21. Oh, good news. 7 and 3 have a common multiple of 21. That means I can create equivalent fractions with 21 as the denominator. What do I do now to create those equivalent fractions? I need to think about when I go from thirds to 21s, that means that I am going to have 7 times as many pieces in that pie. So I'm going to need to have 7 times as many in my numerator. 7 times 2, 14. When I go from sevenths to 21s, that's 3 times as many. Got to do the same thing with the numerator. 1 times 3 is 3. So I have found a common multiple to use as a common denominator and created equivalent fractions. Now I need to subtract. I see I have a little bit of a problem here though. I'm wondering, I'm going to need a little bit more space because look at my fractions. I can't take 14 out of 3. If I only have 3, I can't take 14 out of that, not even in fractions. So I'm going to have to do some borrowing and regrouping just like I would in a whole number subtraction problem. So let's see what that's going to look like. I'm going to ungroup one whole from my whole number 3 here, and that's going to leave me with 2 whole. And that 1 whole is I'm going to group into my fraction. I've got 3 over 21. Since 21's my denominator, I need to think, well, that 1 whole that I took would be like 21 out of 21 plus the 3 I've got here. Well, 21, 22, 23, 24 over 21. And I know that's looking funky, but I don't want you to panic because take a look here. Now, 24 take away 14, I can totally do that, and so can you. In fact, 24 take away 14 is just 10, and again we're counting in a whole that's been broken into 21 equal pieces, so that's our denominator. I still have a whole number subtraction piece that I need to deal with though. 2 take away 1, and that leaves me with 1 and 21, or 10 over 21. Again, last thing I do is ask myself, can this be simplified? And the answer in this case is again no, because 10 and 21 only have the common factor of 1, and dividing by 1 isn't going to change anything for them. So the difference, 1 and 10 over 21, is the simplest expression of the difference between our original 2 mixed numbers. I know this can sound all kind of crazy, but I just want you to remember